So this PowerPoint is about water loss. And water loss will touch briefly on your job as a water conservation coordinator or a specialist or a practitioner. I'm not sure what your title might be. It's not something you'll deal with a whole lot. Typically in conservation, water loss, we equate with water waste, which might be irrigation runoff, or it might be people using water improperly. But when you hear the term water loss, there's a specific measurement behind it that has to be reported. So this is the easiest way to think of real water loss. It starts at your source. You're going to lose some water in treatment. You're going to lose more water in the distribution system before it finally gets to the customer who gets to use it. There's a lot of controversy over how much water loss actually costs a utility. The numbers are often brought in at around 10%, but in reality, in an old system, it can be much higher. So water loss really represents lost revenue and a lost source of supply. If you can correct water losses, then that also means that you're going to increase revenue and you're going to also increase supply. It's kind of like a hidden supply, like conservation is. And I think for a conservation person, that's the best way to think of water loss. So what is it? It's a systemic problem that is only really and truly being addressed now. As I mentioned before, 10% was kind of the magic number. You had this, that was the best management practice. If your water loss was less than 10%, you were considered fine. But the way they often got that number was they backed into it. They said, well, if we're pumping, if we're producing 15,000 acre feet a year, then 10% would be 1,500 acre feet. So how do we come up with a 1,500 acre foot number rather than actually look at what was happening? This went on my whole career, and it's only been in about the last 3 or 4 years that it's been cracked down upon. There is extreme resistance to the process of correcting water loss. I don't know if it's because we have a wealth of older people working in the industry who were used to doing it one way, but you will find that there's just a tremendous amount of resistance to calculating a number that is more accurate. Probably typical water loss is really between 2 and 15%. 2%, you'd be a hero. Okay, I've never worked for a utility where their water loss was only 2%. They might say it was 2%, but it wasn't really. And the older the area is, the more susceptible it is to water loss problems. Makes sense. You have older infrastructure. A lot of utilities don't keep up their infrastructure, so it just becomes more leaky as time goes by. So it's a key conservation strategy of the California Water Action Plan. Speaking of the plan, if you haven't had a time to check it out, it's put out every 5 years by the State Water Resources Control Board and the Department of Water Resources. It's typically late coming out, but it's usually a very large document. Conservation is one small part of it, and there's a lot of regulations that are going to affect conservation in the very near future. And we go over a lot of it in my PowerPoints. So many of the things that I talk to you about, like regulations, for example, come right out of the California Water Action Plan. It really is aimed overall in the water loss section to improve supply reliability. It does you no good to pump from the ground or import water from afar when you're just going to lose it through a bad system of leaks, basically. So SB 555, for those who don't know, SB stands for Senate Bill, required the State Water Resources Control Board to develop standards for urban water suppliers, and they have in fact been working on that. They are fairly far along with it. It might end up being a little bit late, but they've made good progress on that. All water loss standards will have to revolve around the principle that it is economically achievable. So if you have a really old system that just simply needs to be redone from top to bottom, that's not going to be economically achievable. So you would have to pick a goal that was smaller for your particular agency. No agency can go broke trying to prevent water loss. That's part of the law. And then EOs, EOB 3716, and B 4017 direct the Department of Water Resources and the State Water Resource Control Board to minimize water waste through system leaks. These are recognizing that this is actually a real problem, even though it's been ignored literally for years. So it only applies to potable water, and its intent is to evaluate real water losses. There's also an attempt where you have to quantify apparent water losses, which would be theft or data problems. Now, theft is pretty easy to understand. There's not really as much water theft as you would imagine. Occasionally, you'll have a construction company have a hydrant meter from another job. They hook it up onto a hydrant. They don't pay for it. So that does happen, but it's not really a terrible problem. Data problems, though, are. It's kind of on the theory of garbage in, garbage out. So it's a real problem. The main goal of water loss is to identify where they need to assess and repair their current issues. And originally there was a 4-year process for compliance. You'll see on the next slide what you were complying with. We are in, I think, year 3 or year 4 of that 4-year process. I went to some original training on it a couple of years ago. It's pretty complicated mathematically. It's more the engineering department that's going to calculate it because it has a lot to do with how much water you're producing, pipe size, flow, velocity, etc. But you do need to be in contact with engineers and just know that they're working on it. In some agencies, actually it's the conservation person who does that. So there's a software produced by AWWA, and what you're seeing on the right there in that bubble is part of the software score sheet, basically. And they audit the supply and billing, and then they look at production, and then that's how they calculate water loss. It's pretty complicated and time-consuming, and you come up with a numerical score. Now, that numerical score has to be sent to someone else with information and data, and that has to be validated before it's considered an accepted number. AWWA provides the validator training. I would highly suggest to anyone who goes into water to get that validator training. The reason is it's because everybody has to be validated. Everybody is often looking for somebody to do the validation, and they generally charge about $2,000 just to validate data, and it might be a nice little side business for everyone. My one caveat on all of the water loss score is that if you put garbage into your software spreadsheet, you're going to get garbage out no matter what the score actually is. And if you give your validator garbage data and a garbage score, they're going to basically validate that information. Now, that's not to say they never catch anything. They do, but just the same, if there's a long way to go yet. It's come a long way, but there's a long way to go yet on water loss.